presenting a possible and highly probable theory for the collapse and destruction of World Trade Center 1 and World Trade Center 2 based on observation and documented factual evidence. Since the official story of the tower's collapse based on national media reporting, the 9/11 Commission report and official sources, doesn't hold up to the scrutiny of scientifically supported evidence, we must look for answers based on the evidence that is available. Many alternative theories have come forth as to how the World Trade Center Towers 1 and 2 collapsed on September 11, 2001. Conventional explosives, thermite, directed energy weapons, basement nuclear fission device, molten aluminum explosion? None of the proposed theories more accurately explains what happened during that event than does a nuclear fusion reaction. None. Not to be confused with what people consider as a directed energy weapon originating from a remote or distant source. This could be considered a direct energy weapon, a device assembled inside the buildings, a nuclear fusion device. More properly, a nuclear fusion weapon that is sustained by nuclear fissionable material, depleted uranium. This will be explained later. During their lifetimes, people have been repeatedly shown the images of nuclear explosions. So when people hear the term nuclear weapon mentioned, this is the first mental image that comes to their minds. But when it comes to nuclear fusion, this is not the case and not what would happen or could be expected from a nuclear fusion event. Before you can begin to understand what happened that day and what caused the collapse, destruction and effects seen in video from that day, it's important and necessary to have the knowledge and awareness of some electrical properties and physics, and especially nuclear fusion. It is important to understand the major fundamental differences between types of nuclear reactions: nuclear fission and nuclear fusion. Even though these are two different nuclear processes, both can work together, in unison. One reaction working in concert with the other, during the same exact time frame. This fusion-fission combined reaction will be covered later in this video. Typical nuclear fission chain reaction. A nuclear fission reaction yields a nuclear fission explosion. Typical nuclear fusion implosion reaction. Nuclear fusion is the opposite of fission. Nuclear fusion reaction yields a nuclear fusion implosion. During this process, the nuclear fusion fuel pellet or fuel cell is extremely compressed very rapidly until the fuel is ignited and its molecules begin to fuse together. Once the fusion fuel ignites, the fusion reaction begins to rapidly expand, surrounding itself in an expanding cloud of hot plasma gas that is generated by the reaction. This is the exact same nuclear reaction that fuels the sun in the sky. Let's take a look at ongoing nuclear fusion laboratory experiments. Lawrence Livermore National Laboratory. Inertial confinement fusion, how to make a star. Fusion implosion methods by laser. Deuterium, tritium nuclear fusion experiment, September 29, 2010. Lawrence Livermore National Laboratory, indirect method. The nuclear fusion micro-fuel pellet. This device is called the whole realm. The micro-fuel pellet is secured inside. The whole realm is used to reflect micro-laser beams onto the fusion fuel target. The whole realm and its attachment. The fusion fuel pellet inside the whole realm. The whole realm and attachment secured inside of laser lens focal point in the physics laboratory. Whole realm containing the micro-fuel pellet. This is the whole realm and its attachment before the fusion fuel pellet is ignited and imploded. Before and after. This is what remained of the whole realm and its attachment after the fusion reaction took place. Before and after. The whole realm and its attachment are destroyed during the fusion reaction. The resulting energy release of this micro amount of fusion fuel. Nowhere has it been stated these nuclear fusion reactions or the fusion fuel pellets have to be micro in size. Now with a much larger fusion target chamber. A much larger fusion experiment. Larger whole realm target with a larger fuel pellet. Larger nuclear fusion reaction. Nuclear fusion experimental reactors for power generation have rapidly advanced in the past decade. In order to be used in a fusion reactor for power generation or used as a weapon, the fusion fuel cell would need to be considerably larger, possessing more energy and greater power. ITER International Thermonuclear Experimental Reactor. This is a representation of the tokamak nuclear fusion reactor. The fusion reaction is kept contained with a magnetic confinement chamber. Inside the confinement chamber, the nuclear fusion reaction within a field of plasma forms the shape of a torus as seen here. A high-energy magnetic field of the confinement chamber creates the plasma torus confining both plasma and the fusion reaction. If the center section of the chamber is removed, a spherical magnetic field would form. The center of the fusion reaction would contract inward as seen here. Removing the outer magnetic field, both plasma and the fusion reaction would be unconfined. It would then extend outward in all directions, covering an extremely large area as can be visualized here. The strength of the field would weaken in direct proportion with the distance away from the central fusion source. A nuclear fusion reaction that is not confined within a magnetic field is referred to as an inertial confinement nuclear fusion reaction. What would a nuclear fusion reaction look like when not confined by an external magnetic field? There is a good example of an inertial confinement nuclear fusion reaction visible to us on any clear day. It's called the Sun. With a diameter of about 864,938 miles, or 1.392 million kilometers. Although it appears small when viewed in the sky, the Sun is 92,960,000 miles from the Earth and massive in size. Even as bright as the Sun is in the sky, it can be covered from view by a small cloud of water vapor. Some scattered or diffused energy still gets through, and here is seen as very dim visible light. Since nuclear fusion is the process by which stars produce energy, then even a smaller nuclear fusion reaction can be directly compared to smaller stars. The fusion process from beginning to end can be compared to the life of a smaller star. As video evidence of nuclear fusion seen during the Twin Towers collapse will indicate. Understanding nuclear fusion. In nuclear fusion there are different types of fusion fuels or fusible elements used. The fusion reactions are similar. Varying different types of elements added to the fusion fuel can vary the desired effects of the fusion reaction. Most scientists believe the Sun is fueled by proton fusion reaction. Proton fusion is one type of nuclear fusion, as there are other types using different fusion fuels. Some examples are proton-boron isotope fusion, deuterium-helium fusion, muon-catalyzed fusion, deuterium-deuterium fusion, deuterium-tritium fusion. For now we will examine deuterium-tritium nuclear fusion, and later we will look at variations in the fusion fuel of this type fusion method. Laboratory experiments in deuterium-tritium nuclear fusion are carried out in microminiature scale, because of the huge amount of energy released by the fusion reaction process. Whereas nuclear fusion reactions capable of being used as a weapon would be considerably larger in scale. And unlike the hydrogen bomb, which is an additional nuclear fission component used to initiate a combined fission/fusion reaction. Fourth-generation nuclear fusion weapons can be considered pure fusion weapons. Weapons-scale nuclear fusion implosions, initiated by lasers or particle beams. Large-scale inertial fusion devices have been a proposed subject for development for fourth-generation nuclear weapons. Serious implications 2 years prior to September 11, 2001. Basic scaling, how big or small? Fusion/fission thermonuclear weapon scaled to a size much larger than a typical laboratory experiment. W-88 warhead for Trident D5 ballistic missile. Neutrons only? Neutron bomb? This is what it appears to be and has been reputed to be by expert sources. In the case of the W-88 warhead, a very thick layer of both U-235 and U-238 depleted uranium are used to enhance radiation emitted from the weapon by dramatically increasing the amount of neutrons released. Enhanced radiation weapons are airburst weapons designed to kill living beings without damaging exposed buildings or structures, with limited short-term radioactive fallout. Government reports cite these warheads were dismantled and their contents removed. This provides an opportunity for the reuse of the fusion materials they contained. During pure fusion reactions, fewer neutrons are released, and since a majority of the fusion fuel is used up, it produces little or no residual radioactive byproducts. This is why it's necessary to use large quantities of heavier radioactive elements like uranium or plutonium in enhanced radiation weapons. Plutonium atom nucleus 150 neutrons, uranium atom nucleus 146 neutrons, as compared to deuterium. 1 neutron, tritium. 2 neutrons, lithium. 3 neutrons. Since different nuclear reactions react differently, and have different effects and leave their own unique effect or signature. The evidence indicates that no atomic bomb, no hydrogen bomb, or no neutron bomb of the enhanced radiation type was used to collapse and destroy the World Trade Center towers. So what does the evidence indicate was used? The evidence indicates a nuclear fusion device, a hybrid fusion device, that could be considered a pure fusion device. The fusion fuel for this hybrid fusion device can be seen in the U.S. patent 4,297,165, laser-ignited nuclear fuel having an exterior uranium shell to effect tamping. Here tamping means compression. Where deuterium, lithium and tritium, lithium along with a very thin outer layer of uranium is used to increase the fusion energy level and prolong the fusion fuel burn time. A nuclear fusion device using this type of fuel would be both sustained, extended burn time, and controlled, confined within a specific area. In connection with a fusion process, which can be initiated by a high-energy input such as a laser beam, the use of a layer of uranium surrounding the fusion fuel such as deuterium-tritium, or a non-cryogenic fuel such as lithium-deuterium-lithium-tritium. The uranium serves as a tamper layer to contain the fusion fuel and supplement the heating by a fission reaction, which not only increases the fusion yield but increases the time of disassembly, thus materially increasing the efficiency of the fusion system. When deuterium and tritium are forced together under extreme pressure, they create a fusion reaction, releasing a huge amount of energy, a helium atom and a neutron. When an abundance of lithium ions are present, the free neutron bombard the lithium ions, creating more tritium, helium and energy. Additionally, created tritium fuses with available deuterium that's present, continuing the fusion reaction. This nuclear process is referred to as tritium breeding. When small amounts of uranium are added to the fusion fuel, these are divided and further subdivided by neutrons released by the fusion reaction, creating even more neutrons to create more tritium from lithium and more deuterium from helium alpha particles, creating more energy and sustaining the nuclear fusion reaction, releasing even more neutrons to create more tritium from lithium and more deuterium from helium alpha particles. This cycle continues until almost all of the deuterium, tritium, and lithium is expended, with the small amount of uranium being reduced to other elements by fission due to neutron bombardment. This is known as nuclear transmutation. Very similar results can be seen in the research article white paper entitled Fast Fission-Assisted Ignition of Thermonuclear Microexplosions. Here the term micro in microexplosions means considerably smaller than the sun or stars. The term microexplosions is used here to denote its use in a nuclear fusion power reactor, where multiple fusion fuel cells would need to be ignited over a period of time for the continued generation of power. Whereas if used for the controlled demolition of a large building, only one larger fusion fuel cell would be required, and if ignited inside of a building could or would be seen and thought to be the result of a conventional explosive. Internet search term results. Fast ignition fusion concepts. The reaction duration time of this small deuterium-tritium nuclear fusion fuel pellet seen here was only a fraction of a second. In order to increase the reaction time, the duration time of the fusion reaction, the element lithium is added to the deuterium-tritium fuel pellet. Now, consider a larger fusion fuel pellet. A larger deuterium, lithium, tritium fuel pellet would also mean a larger increase in energy released during the fusion reaction. With the deuterium-lithium-tritium nuclear fusion fuel pellet, reaction time is extended. A deuterium-tritium-lithium fusion fuel pellet of smaller size can have the same effect as a deuterium-tritium fuel pellet of a much larger size. By the end of this process, not all of the tritium may be used. This can leave higher than normal amounts of residual tritium in the vicinity. Water samples taken from beneath the collapse site indicated increased levels than normal tritium levels. Just like the sun, a nuclear fusion reaction can be obscured by heavy dust, or even completely blocked from sight by a solid object, such as if it were inside a building. An unconfined, inertial nuclear fusion reaction would obey the law of gravity. A tremendous amount of energy that could quite easily melt, vaporize and or dissociate the molecules of any material below or around the reaction, as it is pulled downward by Earth's gravity. Also the release of neutrons from the fusion reaction that would be absorbed by nearby materials. The theory of molecular dissociation by neutrons. Nuclear fusion creates an energy surplus, as was evidenced during the collapse of World Trade Center Towers 1 and 2. Molecular dissociation can also be caused by resonant standing waves from the huge volume of high-energy electromagnetic waves nuclear fusion produces. Strong resonant standing waves creating vibrational and torsional strain and stress on an extreme scale which can shear materials apart into relatively small size particles. Resonant standing electromagnetic waves create stress and torsion affecting material at the molecular level. At higher frequencies in close proximity to the energy source, weaker materials would shear into small particles. Depending on the frequencies involved, even breaking weaker materials down to the micron size level. Dust particles of uniformly small size, in the micron size range, 1 micron equals 1,000th of a millimeter or 0.03937 of an inch. This effect can be seen in the abundance of uniform-size particles contained in the WTC dust. United States Geological Survey particle samples, 0.3 to 30 micron range. Characterization of the dust, smoke aerosol that settled east of the World Trade Center. Aerodynamically separated particle samples 10, 53 micron diameter in the 30 percentile range, greater than 53 microns in the 50-60 percentile range. Sieved particle samples less than 75 microns in the 30% range, 300 microns in the 40% range, greater than 300 microns in the low 20% range. Much of the uniform-sized particles originated from the vast quantity of fireproofing insulation used in the World Trade Center buildings. The steel floor supporting joists were sprayed with fireproofing insulation. This insulation, when originally sprayed, consisted of longer fibers, which were later broken down during the collapse event. The outer steel spandrels were also sprayed with insulation prior to the attachment of the aluminum cladding. Any dissociation involving resonant standing waves would primarily affect weaker material and conglomerate materials of a cohesive type structural makeup, such as insulation or concrete. According to Gauss's law, electromagnetic waves have an extremely low depth of penetration in all metals, and this includes steel. What this means is that, actually and factually, steel cannot be turned into dust using electromagnetic waves. Electromagnetic waves can induce heating in steel, but only by extreme heating can steel be turned into smaller particles or a vapor. Hard evidence of extreme temperatures and the abundance of microspheres found in the WTC dust. Evidence obtained from World Trade Center dust samples are without a doubt indicative of extremely high temperatures having occurred in the collapse of the Twin Towers. Steel samples were collected which show the effects of vaporization. Erosion of steel that could only happen from exposure to extremely high temperatures. From the R.J. Lee Group report, shows high levels of iron microspheres, much higher than seen in any other source. Iron spheres, along with silicate spheres seen in abundance in the dust from the World Trade Center collapse. In addition to the spherical iron and aluminosilicate particles, a variety of heavy metal particles including lead, cadmium, vanadium, yttrium, arsenic, bismuth, and barium particles were produced by the pulverizing, melting and arc combustion of the host materials such as solder, computer screens, and paint during the WTC event. Combustion-related products are significant WTC dust markers, particularly if seen in combination. However, it is worth noting that fly ash and partially combusted products can occur in trace concentrations in ordinary building dust, but not in the concentrations observed in WTC dust. Iron spheres, along with silicate spheres seen in abundance in the dust from the World Trade Center collapse. Dust samples examined under traditional optical microscopes show exactly the same results: metal spheres. Iron-rich sphere from World Trade Center dust is seen under scanning electron microscope. Melted slag wool fiber is produced in temperatures exceeding 1480 degrees centigrade or 2700 degrees Fahrenheit. Particle sample from the R.J. Lee Group report. Particle exposed to extremely high temperatures. Multiple research reports noted an abundance of particles with a Swiss cheese appearance, having been exposed to high enough temperatures to cause a boiling or vaporous melting. World Trade Center collapse sample as compared to a normal sample. Temperatures referred to by all reports are well beyond any temperatures seen in past building fires or obtainable by jet fuel fires. An initial report issued by the U.S. Geological Survey team reported not finding the metal molybdenum. A later Freedom of Information request revealed an unreported molybdenum sphere found in the World Trade Center dust samples. The melting point of molybdenum is given as 2623 degrees centigrade or 4753 degrees Fahrenheit. R.J. Lee Group report shows evidence of metal, non-metal coatings on WTC dust particles. These type coatings are not normally found on dust from building demolitions or building materials. Their findings report that the coating material first vaporized then condensed on the dust. R.J. Lee Group Report 3.0 Other World Trade Center dust characteristics, coatings, the amount of energy introduced during the generation of the WTC dust and the ensuing conflagration caused various components to vaporize. Vapor phase components with high boiling point and high melting point would have, as they cooled, tended to form precipitated particles or thin film deposits on available surfaces through condensation mechanisms. The results of this process would be the presence of a thin layer of deposited material on the surfaces of the dust particulate matter. Many of the materials, such as lead, cadmium, mercury and various organic compounds, vaporized and then condensed during the WTC event. One of the major concerns noted by the R.J. Lee Group report was the amount of lead as one of the metals found in a dust coating. Just keep in mind that the temperature required to volatilize/boil lead is approximately 1740 degrees centigrade or 3164 degrees Fahrenheit. This chart in Table 1 of another report emphasizes the extremely high heat that is absolutely required to melt the metals and materials involved in the World Trade Center collapse. The report's extremely high temperatures during the World Trade Center destruction also states the findings of the Worcester Polytechnic Institute report. Affected steel temperatures were 1000 degrees centigrade or 1832 degrees Fahrenheit. The other data summarized here point to significantly higher temperatures than 1000 degrees centigrade. This heat-fused conglomerate of various material from the World Trade Center collapse has been named the meteorite. This is another example of a conglomerate of extreme high heat-fused building material taken from the World Trade Center debris. To the casual observer, this evidence may not seem very convincing or of any consequence. But to those who understand the processes involved, this presents serious implications.
As the steel began to soften and melt, the interior core columns began to give. Then you had this sequential failure that took place where it all pancaked one after the other.
These are images of the progressive or pancake collapse of buildings. Had the World Trade Center towers suffered from a progressive or pancake collapse, there would be piles of floors layered upon each other in the debris field once the floors collapsed around the core column. The integral strength of the 47 interconnected central steel and concrete core columns would have left the majority of the core standing intact. But this was not what was seen during or after the World Trade Center towers collapse. A graphic video clip demonstrates how a sustained controlled nuclear fusion reaction could have been used to collapse WTC towers 1 and 2, as can be seen in this simple graphic representation. The one thing that normally would not be seen in an inertial nuclear fusion reaction would be the magnetic field and gravitational field generated by the fusion reaction itself. The energy emitted from the nuclear fusion reaction would extend in all directions. Here is a more accurate graphic image depiction. While a huge amount of energy is released in the near vicinity of the fusion reaction, the electromagnetic gravitational field extends much further beyond that energy release. Evidence of the magnetic field could be seen if it interacted with dust particles that were in the vicinity of the field. The following video footage sequences show evidence of a magnetic/gravitational field effect. This is actual national media video footage of the September 11, 2001 collapse of World Trade Center North Tower. Once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. ABC News. World Trade Center South Tower collapse September 11, 2001. Dust from a distance being pulled back into the building implosion. This exact same effect is seen in each similar camera angle perspective of WTC collapse videos. Lighter particles being pulled back into the center of the collapse of the building. The effect of either one or a combination of electrostatic, electromagnetic or gravitational fields. Now view the same clip again with the electromagnetic field image superimposed in the dust of the collapse. As the collapse progresses, lighter dust particles are deflected into the collapse, while heavier debris is ejected, leaving a plume of vaporized material such as steel, silica, calcium carbonate and other material in the air above. As the collapse progresses, lighter dust particles are deflected into the collapse, while heavier debris is ejected. Leaving a plume of vaporized material such as steel, silica, calcium carbonate and other material in the air above, with a majority of the debris pulled downward into the center of the collapse. The result of a high increase in the gravitational field effect of the imploding nuclear fusion reaction. Next video: World Trade Center North Tower collapse. Watch once again, this time slower. Evidence of the magnetic, gravitational field can be seen when a comparable field image is inserted into the frame of the collapse video, as shown in this next clip. The magnetic, gravitational field would have little effect on heavier debris, but only affect lighter dust particles. Let's look at this clip again, only this time with the video frame rate slowed down to 1/2 normal speed. We'll look one more time, at half normal speed and zoomed in. We'll watch this clip again. This time I've added both the field effect and a representation of the central fusion source, so that you may visualize the effect of this highly probable possibility based on the visual evidence. A nuclear fusion reaction ignited in the center of the buildings would melt and even vaporize part of the core columns, along with dissociating the concrete in the surrounding floors, along with other materials on those floors. Anything in the vicinity of the hot plasma field and the fusion reaction as it descends through the central core of the building. Only materials within a specific proximity range to the fusion reaction would be affected by the reaction, which appears to be centralized in the buildings. The result of the inverse square law, where the intensity of the field is inversely proportional to the square of the distance from its source, an energy field weakens as it travels away from its source. This next media clip shows an anomalous effect, which can only be explained by means of nuclear fusion. A gravitational effect which is a direct relationship with the end of the life of a white dwarf star, the end run of a fusion reaction. A significant increase in gravitational attraction. This effect is seen in the dust at the end of the South Tower collapse video sequence. The fine dust particles are pulled into the center of the collapse, right up until the end of the collapse. White dwarf stars. gravity comparison. White dwarf star Sirius B, its surface gravity is such that a person who weighs 180 pounds on Earth would weigh 50,000 tons on Sirius B. White dwarf star is a star of small size and extremely dense mass. The reduction of size with the same density will cause an increase in gravity. The same gravitation increase would noticeably affect smaller, lighter particles. When compared to the enormous size of a white dwarf star, think of yourself as the size of a particle of dust. This next footage is WNBC NIST video of the lower part of the North Tower during its collapse. I'll slow down the video clip, and a better view can be seen. These are effects that are seen in the World Trade Center collapse videos, that either elude or perplex the average viewer, who does not possess the knowledge or only limited knowledge in order to understand the basis of what is seen. Conventional explosives do not attract the lighter particles formed from the ensuing explosion back into the area of the explosion or a continued series of subsequent explosions. Neither does thermite. Conventional explosives do not create a sustained high heat for a sufficient time duration to vaporize materials to coat large quantities of the dust formed during its detonation. The detonation of high explosives occur extremely fast. Velocity of detonation of high explosives range approximately between 4,250 meters per second or 14,000 feet per second and 10,000 meters per second or 32,800 feet per second. Extreme high-energy lasers were developed during the 1990s, and their size reduced to fit on a tabletop. These became known as petawatt tabletop lasers. Tabletop petawatt lasers. Publication date, October 10, 1997. One petawatt is equivalent to 1,000,000,000,000,000,000,000 watts of power. Also during the 1990s, huge improvements were made in laser optics without sacrificing the power of the laser's energy. This made inertial confinement fusion possible on a larger scale. Large laser lens optics. How this scenario could be accomplished? With as few as 6 tabletop petawatt lasers used in a crossfire reactor configuration as seen in this image. Scaled to an approximate size. Relatively compact, less complex than installing thermite or explosive throughout the entire building. Once ignition occurs, subsequent melting, vaporization, dissociation, and the ultimate collapse begins, along with the resulting electromagnetic and gravitational fields. The fusion device could have easily been transported and delivered disassembled to the World Trade Center buildings, and reassembled inside the upper floors of the buildings. Boxed in wooden packing crates, it would have the appearance of replacements for ordinary machinery already in use in the World Trade Center towers.
The FBI has now put out a nationwide APB, all points bulletin, for a white Chevy van with New Jersey registration. Written on the back is Urban Moving Systems. Apparently there are 3 male occupants. Let's repeat that. The FBI has now put out an APB, an all points bulletin nationwide. They're looking for a white Chevy van with New Jersey registration, and written on the back of the white van are the words Urban Moving System.
So, was this actually the mysterious art group named Gelatin, working unobserved inside the World Trade Center towers, or were they the crew tasked assembling a nuclear fusion device inside the World Trade Center towers? In order for this to be done, it would require a huge amount of money that would need to be unaccountable and untraceable. September 10, 2001, U.S. Secretary of Defense Donald Rumsfeld.
According to some estimates, we cannot track $2.3 trillion in transactions.
The next day, September 11, 2001. The subsequent invasion of Afghanistan. Months before September 11, 2001, a United Nations survey team conducted an annual opium poppy survey in Afghanistan, and they issued their annual report. This report concisely stated that the then ruling Taliban regime had strictly forbidden the growing of opium poppies by Afghani farmers, and that ban was effectively being actively enforced by the Taliban and adhered to by Afghani farmers. Some U.S. national news media sources reported the UN findings, like this report from the Laredo Morning Times. Gettysburg Times, Gettysburg, Pennsylvania, February 16, 2001. New York Times, New York, New York, May 20, 2001. Then came September 11, 2001. Then, before the end of the month of September 2001, the United States Central Intelligence Agency began a covert invasion of the country of Afghanistan. The code name for this operation was Jawbreaker, and was put into effect on September 26, 2001. The Jawbreaker team established a base of operations for the arrival of the U.S. Special Operation Command (SOCOM) and the Joint Special Operations Command (SIC), Joint CIA/Military Operations, who arrived in Afghanistan a month later on October 26, 2001. This was before the full military invasion of Afghanistan, several years later.
They have to grow the opium because now the population is, they have these opium fields and we are tolerating it. They have these opium fields and we are tolerating it. We are tolerating the cultivation of the opium. Let me introduce Lieutenant Colonel Brian Christmas. He's the commanding officer of the 3rd Battalion, 6th Marines, and in a sense, you're watching as this opium is being grown. I know it grinds at your gut. How do you deal with it? What are you doing about it?
Well, frankly, this is a part of their culture. So while it might grind in my gut, it's what they do. We provide them security. We're providing them resources. We're here to help them with that security and those resources.
But I fault the politicians for putting the Marines in this position, where we can't eradicate these crops. And the Marines are doing the good thing. And if you want to see exactly how close the vast fields of poppy, the opium poppy, are, just take a look at this. I want to show you how prevalent it is. Just in the shadow of the United States forces, I want you to follow me into this compound. Just scant feet away. Open the old door, the door that has been here for quite a while, and what you see is a wonderland of opium.
The U.S.-led war against the Taliban had failed to focus much effort on Afghanistan's heroin production.
And if you want to see exactly how close the vast fields of poppy, the opium poppy, are, just take a look at this. I want to show you how prevalent it is. Just in the shadow of the United States forces, I want you to follow me into this compound. Just scant feet away. Open the old door, the door that has been here for quite a while, and what you see is a wonderland of opium. A wonderland of opium, as far as the eye can see. This is a country in which the most lucrative crop that can be grown is the opium poppy. Regular farmers everywhere. There is poppy everywhere. This is the season for poppy everywhere. Everybody is making a ton of money off these drugs.
News article, Fayetteville Observer, Fayetteville, North Carolina, February 17, 2012. Opium is not Afghanistan's only highly sought-after resource. What is Afghanistan's not well-known important resource? Lithium. The U.S. has known about the vast Afghanistan lithium reserves since the Russian occupation of Afghanistan during the 1980s. United States Geological Survey International Strategic Minerals Inventory Summary Report, August 7, 1990. Lithium. Lithium is not just important for batteries, laptops and tech gadgets. Through tritium breeding, lithium can produce tritium, a highly valuable and sought-after nuclear fusion fuel. Remember this? Tritium breeding from lithium. Remember this? ITER, tokamak nuclear fusion reactor, which can more efficiently operate using the fuel pellets described in United States Patent 4,297,165. Fuel pellets for controlled nuclear fusion. Whoever controls the supply of lithium controls the future of nuclear fusion and the enormously huge profits involved in future lithium sales. Iron-rich sphere from World Trade Center dust sample. World Trade Center sphere statue before September 11, 2001.